Tonight we have a counting problem, what it amounts to, a combinatorics problem for a large exponential. Let me write down an example of what I'm asking for here. Let's say 3, 9, okay. Now, this 5-digit number has two 9 digits. I'm just writing it like this to avoid any tongue twisting here. 2 9 digits. Okay. Again, it's very simple. This is a 5-digit number and 2 of the digits are 9. So this has 2 9 digits. That's manifest. Now this one's clearly a lot harder. We have an 8-digit number comprised of 9s raised to the 5th power, and we want to know how many 9 digits n has. Now a simple result right here is 10 to the n minus 1 is n 9 digits. It has n 9 digits. Okay. Now again, that's certainly simple enough. For example, 10 squared minus 1 equals 99, and there's certainly 2 of them there, right? Some people might want to say has exactly n 9 digits. Okay. Now let's move along and look at our approach here. Of course, this result begs for the usage of the binomial expansion. Okay, so we rewrote our n based on this truth right here, and the rest of this is just the binomial expansion. These represent the binomial coefficients. 5 choose 1 is 5, 5 choose 2 is 10. The symmetry of the binomial coefficients, you get 10 again, and then you close with 5. Okay, now let's see here. The big idea here is to actually group them in pairs of 2, it turns out. Not something I would have discovered. I saw this on an SMO prep channel. And if you look right here, we can factor out 10 to the 32nd from the first 2 terms. From this term and this term, we can factor out 10 to the 32nd. Now notice that means you're going to tack on 32 zeros to whatever this number is. So you see there's going to be a lot of spacing here. And I'm not going to write all that out, but notice these high powers of 10 are going to put a lot of trailing zeros, which is going to separate them from the other terms. And again, I'm just going to say that. I'm going to assert that without trying to write it all out. It's a little too much trouble, but that's very easy to believe. You're going to have 32 trailing zeros to whatever this number is. Now, this number right here would be, what would it be? It would be 9, just the parenthetical piece here. It would be 7 9s and a 5, right? What do we have here? 5, 6. Is that 7 9s right there? 1, 2, 3, 4, 5, 6, 7, and it'll end in 5, right? And then there will be a bunch of trailing zeros here, folks. A bunch of trailing zeros. In fact, I guess 32, right? Okay, so there'll be 32 trailing zeros to separate it, so to speak, from the rest of these terms. Okay, now, so right here we have 7 9s isolated. Okay, so there's 7. I shouldn't, if you'll allow me, I'll write it like this: 7 9s. Okay, I don't want to say 79, but 7 9s on this very first term, insulated from the rest of the terms. Now, right here, there's going to be, in a similar fashion to what I said earlier, there will be 8. I won't write it out, but there will be 8 9s. It'll be exactly this term with a 9 at the end of it. Okay, I'll go ahead and write it out. 2, 3, 4, 5, 6, 7, 8. Okay, there's 8 9s right there. And again, I'm just writing down the parenthetical quantity because this 10 term, the 10 to the exponential, just adds 17 trailing zeros to this, and it'll give it separation from this. Okay. Now this one's slightly trickier. This would be equal to 5,000, right? But I mean, excuse me, 5 followed by um, 8 trailing zeros. But when you subtract 1 from that, you would actually end up with 4, right? Just massive borrowing going on, I guess. So this would be 4999 8 times. What do I have? 1, 2, 3, 4, 5, 6, 8. Okay. So we have 8 nines here. I'll write it the same way just for consistency. And again, we have 8 nines here. Okay, and y'all, that looks like it adds up to 7 plus 8 plus 8 is 16 plus 7 is 23. So there are 23 nines. Okay, 23 nines is what I'm getting. I like the idea of this because of I didn't really think about this too much really until I noticed that this high power of 10 just jacks the thing up with a lot of trailing zeros, separating it from the closer terms. I mean, from the next pair of 2. All right, and then the 7 nines here happened just because we had to have a 5 at the end, and that excluded the 9. This one just is exactly what you'd expect to be. It's 8 nines. Then right here, this one was 8 nines in a different sort of way than this was 8 nines, right? Because the 5 in front led to a borrow condition where all these 8 nines still survived, right? So, but in any event, this 23 is what I got as the answer, folks. So the answer is 23. Okay, until next time.